Leonardo Pisano Fibonacci was born in Pisa, Italy, around 1180, although many sources of information contradict his birth date, and he adopted his professional name of Fibonacci, meaning son of Bonacci. During his life, Fibonacci was a mathematician who mastered geometry, arithmetic, algebra, and trigonometry, and aside from introducing the Hindu-Arabic numeric system, including 0 to decimal places, to Western Europe, he established what we now know as the Fibonacci sequence. A number sequence can be explained as a group of numbers which continue to follow a pattern, such as 2, 4, 6, 8, 10, 12, 14. Fibonacci sequence is a number sequence that works by adding the previous two numbers together. So, if you start at 1 and add 0, you get 1 by adding the previous numbers together, which is 1 plus 1 equals 2. The next previous two numbers are now 1 plus 2, which equals 3. Okay, so the next number in the sequence would be 2 plus 3, which equals 5, and so on into infinity. Binet in 1843 introduced the formula to work out the nth number in the Fibonacci sequence. By the nth term of a sequence, we mean an expression that will allow us to calculate the term that is in the nth position of the sequence. So as an example, in our sequence of Fibonacci, we have various terms or positions. Term 1 equals 1, term 2 equals 1. Term 3 equals 2, term 4 equals 3, term 5 equals 5, and term 6 equals 8, etc. Binet's clever formula can be followed to work out the nth term of a sequence. The Fibonacci sequence can also be found in nature. These include flower petals, pine cones, seed heads, vegetables, fruit, and leaf arrangements. This image demonstrates a Fibonacci sequence in the number of stems progressing. This image shows that the number of seeds is linked to the Fibonacci sequence. Another thing in nature is if you look at a pine cone, you can see that the scales of the cone make spirals. Some go to the left and some go to the right. If you count the numbers of scales at each level, you'll find that they will follow the Fibonacci sequence. Mathematicians have also discovered that the golden number ratio, roughly 1.618, exists when the two numbers within a Fibonacci sequence are divided from each other. So this indicates that ancient Greeks may have been aware of the Fibonacci sequence, as they used the golden rule in their buildings, such as the building of Parthenon. So there you go, the Fibonacci sequence, which sits next to other sequences such as the arithmetic sequence and the geometric sequence. Wow, I could create my own number sequence. It would start with one number, half it, then times it by 3. For example, 14, 7, 21, 10.5, 31.5, 15.75. I would call it the Eve sequence.